This is video 2 in lesson 2 of unit 6 for chemistry 1. So in this video, we are going to look at how to determine the number of atoms of elements in compounds with coefficients. So here is the formula for ferric oxide. So we know that these subscripts are written after the element and they tell us how many atoms of each substance we have. So there are 2 atoms of iron and 3 atoms of oxygen. But if we put a coefficient of 5 in front of this compound, we would then have to distribute that 5 to everything that's after it. So we'd have to multiply the coefficient by the subscript. So 5 times 2 would give me 10 irons, and 5 times 3 would give me 15 oxygen atoms. So with that, if we have parentheses in a compound, it can get a little bit more complicated. So we basically have to multiply the subscript inside of the parentheses by the subscript outside of the parentheses and then by the coefficient. So if we look at this example, so here we have titanium 4 nitrate. So this is going to be the first example of what we do. So with this, we have 3 of this entire molecule. So we have to take this 3 and distribute it to the titanium. But then we also have 3 of these NO3 groups, but we have a 4 on the outside of the parentheses. So this 4 means that in the compound, we have 4 NO3 groups, but we have 3 of the 4 NO3 groups. And that might sound a little bit confusing, but if we follow this, we multiply the subscript inside the parentheses by the subscript outside and then by the coefficient. So with this, our titanium is not inside of here, so we only have 1 titanium in the compound. So 1 times 3 gives us our 3 titaniums. The nitrate group here, there's 1 N inside times 4, which is 4, times 3 gives us 12 N's. So we take the 1 inside times the 4 times the coefficient. So for oxygen, we have 3 times 4, that's 12, times our coefficient, 3, that gives us 36 oxygens. So what I would like you to do is to pause this video when I tell you to, and then do these problems. And if you get some really big numbers, especially for number 3, that's fine. You might even need a calculator, which is fine. So go ahead and pause this now. So now that you're back, we can look at the answers. So the first one should be pretty easy because if we cover up the coefficient and we look at chromium 6 chloride, we have 1 chromium and 6 chlorines in each compound, but we have 5 of the compounds. So 5 times 1 gives us 5 chromiums. 5 times 6 gives us 30 chlorines. Number 2, little bit more difficult because we have zinc acetate. So for zinc acetate, because zinc is positive 2 and acetate's minus 1, we need 2 acetates in the compound. But we also have a coefficient of 2 in front. So now we have to multiply 2 different times for anything that's inside of here. So for zinc, which is not in the parentheses, it's understood to have 1 zinc. So 2 times 1 gives us 2 zincs. Everything in the parentheses, we have to multiply by the subscript outside and then the coefficient. So for carbon, we have 2 times 2 times 2, which is 8. For hydrogen, we have 3 times 2 times 2, which gives us 12. And for oxygen, we have 2 times 2 times 2, which is 8. For this compound, which is manganese 7 dichromate, manganese does have a subscript, but it's not inside the parentheses. So we just take 3 times 2, which gives us 6 MNs. But now when we look at chromium inside the parentheses, it has 2. On the outside, it's 7. So 2 times 7 is 14, and then we have to multiply it by the coefficient of 3. So 14 times 3 is 42. For oxygen, we have 7 inside the parentheses, but we have 7 dichromate groups. So 7 times 7 is 49, then times 3. So 49 times 3 is 147.